All right, hello. So, Java in 2018. Change is the only constant. In the past year, we've changed the Java platform in three ways that we never have before. First, we took this massive monolithic thing that had grown monotonically over time, and we sliced it up into 26 standard modules. Second, we removed the Java EE and Corba modules and some other APIs, leaving us with 19 standard modules. And third, we left behind our historically grand and majestic, but slow-moving and frankly unpredictable release model, in which we shipped a major release every 2 to 5 years. We replaced that with a rapid cadence release model, in which we ship a feature release every 6 months on a strict time-based schedule. Now, modularizing the platform and removing some modules did break a few things, and many have wondered, and understandably so, whether the Java ecosystem will be able to keep up. Taken together, all of these changes are, frankly, somewhat scary. But maybe they're not as scary as you think. Why did we make them? Because adapt or perish, now as ever, is nature's inexorable imperative, according to H.G. Wells. Or if you prefer a more modern formulation, adapt or die. So saith Andy Grove. We must change Java in new ways because its competitive environment is very different than it was 20 years ago. There have been two big changes. One is that many popular platforms now ship new features around once a year, if not every 6 months. If Java is to remain competitive, we must move it forward faster. The second change is applications are now packaged and deployed in different ways than 20 years ago. Whether to the cloud or in packaged apps published in app stores, if Java is to remain competitive, we must adapt it to these new environments. Let's look at the first big change, modularizing the platform. This is where we ended up. Nice clean module graph, beautiful, easy to understand, 26 standard modules. The JDK, of course, has these standard modules plus a bunch of other non-standard modules that contain things like development and debugging tools, service providers, and JDK-specific APIs. This is not where we started. We started with a spaghetti bowl of tightly coupled platform components with sometimes surprising interconnections. Slicing all this up while maintaining as much compatibility as possible took years of painstaking refactoring and delicate surgery. We were finally able to deliver on that in JDK 9. Now, modularizing an old code base can be a ton of work, but modularizing the platform yielded many benefits. One benefit is that it's more flexible. A module names the modules upon which it depends, so the module system can ensure the reliable configuration of consistent subsets of the platform. Most applications, after all, don't need all of these modules. If you have an app that only uses the SQL module and the base module, then you can link a custom runtime system that contains just those two modules plus any others that they need. You can package this custom runtime system with your app in smaller Docker images, smaller App Store packages, things that are tens of megabytes rather than hundreds. To do this, you don't need to modularize your app. You can do that if you want. There are many good reasons to do so, but it can be an awful lot of work, and it's probably not worth it. If you have a big app that's in maintenance mode, is not going to change much, then it may well be best to let it be and don't bother with modularizing it. That's okay. Another benefit of the modular platform is that it's more secure. A module exports specific packages only for use by the modules that depend upon it, so the module system can enforce strong encapsulation. How much more secure is it? Of the 6 high-impact, zero-day vulnerabilities reported since JDK 7 in 2011, 3 of them would have been prevented if we'd been able to strongly encapsulate the JDK's internal APIs. A final benefit of the modular platform is that it's easier to maintain. Yes, the JDK does contain many internal APIs that were never meant to be used by external code. For decades, we've been warning developers against using these. They've done that anyway, of course, sometimes in some disturbingly popular libraries. Now, to be fair, in some cases, they were after critical functionality that they could get no other way, such as some of that which is found in the SunMISC unsafe class. In many cases, like all of us can be from time to time, they were just lazy. Why write your own base64 decoder if there's a perfectly good one over in the SunMISC package? For 20 years, we've therefore treated many internal APIs as if they were standard. We've been reluctant to change them because we don't want to break people's code. But this has made the platform harder to maintain and harder to evolve. With strong encapsulation, we can close off all access to the internal APIs of the JDK, simply by not exporting the packages that contain them. Now, if we did that right away, we would definitely break a lot of existing code. So we're taking a more gradual, nuanced approach, since migration takes time, especially in such a large ecosystem. Starting with JDK 9, and at least through JDK 11, if your code uses JDK internal APIs, then it will not compile, but it will run, yet it may generate warnings at runtime. Now, by your code, I mean not just the code that you write yourself, but all that useful stuff that you downloaded from Maven Central and merged into your app. We've deliberately relaxed the strong encapsulation of legacy JDK internal packages for now at runtime so that old code continues to run. We'll eventually strengthen the encapsulation of these packages once we've provided standard APIs for the critical internal APIs and once everyone has had a chance to fix their old code. When we do that, in some future release, code that uses JDK internal APIs will not run. In the meantime, here's an example of the kind of warning you might see if you haven't seen one of these already. This is Jython, a Python interpreter written in Java running on JDK 9. These warnings tell you several things. They tell you that an illegal reflective access operation has occurred. They identify the code responsible and the internal API that it accessed. In this case, it's over in some of the internal new I/O code. They suggest that you report this error to the maintainers of this library, so you can do your part to help bring the ecosystem forward. They tell you how to get additional warnings if you want to see them. By default, only the first such warning will be shown. Your application might have dozens or hundreds or thousands of others, and if you want to work ahead of the game, you might want to look at them. And finally, it does remind you that all illegal access operations will be denied in a future release. To help you get ready for that future, when such code will not run, we introduced a new tool in JDK 9 called JDEPS. If you run JDEPS against an existing jar file with the JDK internals option, it can detect via static analysis most uses of internal APIs. As an example, here it detected the use of Sun Security X509 X500 name, which is an internal API, and it even suggested down at the bottom a standard replacement. Note that says since 1.4. That's Java. That replacement has been there since Java 1.4, which shipped in 2002, which was 16 years ago. So there's really no excuse not to be using the standard replacement. Okay, so the modular platform, it does break some things, but it doesn't break everything. If your code uses only standard Java SE APIs, then it will most likely work without change. I do say most likely here because there are some very minor differences. We've removed a few obscure, rarely used methods and mechanisms to enable a clean modularization. And there are some small behavioral changes that honor the specification, but in rare cases, they might break existing code. If you want to know more, have a look at JEP 261, which lays out all of the compatibility-related changes in great detail. Beyond that, to learn more about the module system and the modular platform, I can recommend all three of these excellent books. So, the modular platform enabled the second big change of the past year. We've reduced the platform by actually removing things for the first time in Java's history. Well, at least the first time on purpose. We removed the Java EE and Corba modules in Java 11. They're gone. Why? The details are all in JEP 320, but in a nutshell, all of these components are costly to maintain. They've been the source of multiple security vulnerabilities over the years. And nowadays, they're either available elsewhere, as in the case of Java EE, or they're really no longer that relevant, as in the case of Corba. We removed some other smaller things too. As I mentioned, in order to modularize the platform cleanly, we removed some fairly obscure methods in Java 9. Most of these have to do with configuring property change listeners on various core APIs. Frankly, these probably never should have been added in the first place, but there they were. We only removed these after analyzing lots of code out in the wild to see if anyone was using them, which hardly anyone was. While we were at it, we also removed a pointless constructor that snuck into Java 8. That was Brian's fault. We removed more methods in Java 10. All of these methods are ill-defined, actively harmful, don't work, or don't do anything useful. We removed yet more such methods and one class in Java 11. Now, removing things can cause breakage, but to ease that pain, we always give advance notice by deprecating APIs to be removed at least one release in advance, if not more. As an example of that advance notice, here are all the APIs deprecated in Java 11 for removal in a future release. If you look closely, you can see that many of these are finalized methods in the core APIs. We're removing those because finalization is a fundamentally broken mechanism that we've replaced with something better. When an API is deprecated for removal, that's always noted in the API's Java doc. For example, this is a method, the Java doc for a method in the Java Lang runtime class. It's named trace method calls. How many people have ever invoked this method? Nobody. Yep, that's what I figured. So this method actually dates back to the very dark ages before we had just-in-time compilers. We only had bytecode interpreters. It's designed for controlling bytecode interpreter and requesting that method invocations be traced. As you can see, it's been deprecated for removal. It was intended to control method call tracing. It has been superseded by JVM-specific tracing mechanisms. This really isn't any great loss. As you can see from the subtle and sophisticated specification, not implemented does nothing. If you compile source code that uses an API that's deprecated for removal, then the compiler will, helpfully, warn you about it. Dr. Deprecator would be proud. So, popping back up. First, we modularized the platform. Then we trimmed it down. And then we started moving it forward at a faster pace with a new release every 6 months. How can that possibly work? That's actually what I asked when it was first suggested a few years ago. Let's look at a timeline. We shipped JDK 9 last September. We shipped 10 this past March. We shipped 11 just 7 weeks ago, and we'll ship 12 next March, and so on, every 6 months, like clockwork. A feature release can contain any kind of feature, a language feature, a library feature, a performance feature, a JVM feature. It can even contain a feature removal. For this to work, features can go in only when they're nearly finished, because we can no longer slip a release in order to fix a broken feature. But that's okay. If a feature misses the current release, the next release is just 6 months away. So at the beginning of all this was JDK 9, the final massive JDK release. JDK 9 contained 90 JEPs, along with thousands of smaller enhancements and bug fixes. It shipped 3 years and 6 months after JDK 8 in 2014, with 2 major slips to the schedule. Oracle engineers did much of the work in this release, but not all of it. 6 JEPs came from outside Oracle by contributors from Red Hat, Linaro, SAP, and a couple of individuals, Doug Lee and Laurent Borges. Amongst these JEPs were 3 entire CPU ports, some significant performance work, and a new 2D graphics rasterizer. So after all that, what was going to be in JDK 10? One worry we actually had about the 6-month cadence is we might have 0 features in a release. I mean, that's theoretically possible, right? If we're going to ship like clockwork, no features are ready, we'll ship a release, it'll have a nice number, but it'll just contain bug fixes and some small enhancements. Happily, that turned out not to be the case. JDK 10 contained 12 JEPs, including 1 language feature, local variable type inference, better known as var, more performance work, and a massive refactoring of the code base into a single Mercurial repository. Again, Oracle did much of the work, but 2 JEPs came from other contributors. Roman Kenke of Red Hat contributed a new GC interface to the hotspot JVM, and some engineers from Intel enabled heap allocation on alternative memory devices. This pattern continued in JDK 11, which had 17 JEPs, including some long-needed JVM improvements, a new HTTP client API, the ability to launch single-file source code programs without compiling them yourself, and TLS 1.3 just in time for the final Internet standard. Oracle, again, did most of the work, but 3 JEPs were contributed by others. Engineers from Belsoft and Cavium contributed some improvements to ARM64 performance. Alexei Shipalev of Red Hat contributed the Epsilon garbage collector, and Jean-Christophe Baylor of Google contributed low overhead heap profiling. Finally, that brings us to JDK 12, still in development for delivery next March. There are 5 JEPs so far, all from Oracle, including a micro benchmark suite for the JDK itself and 2 preview language features, switch expressions and raw string literals. These preview language features, they're preview in the sense that they're in the JDK, but they're not enabled by default. They're there to encourage you to play with them, try them out, and tell us what you think. Please do send us feedback before we bake them in and turn them on by default. If you'd like to do so, by the way, you can get the builds here. As you can see, what has changed is not the rate of innovation. We're still continuing to innovate at a healthy pace. What has changed is the rate of innovation delivery. In 3 years, by 2021 or so, we probably will have merged around 90 JEPs, just as we had in JDK 9. These feature releases aren't just about JEPs, of course. Each contains many smaller enhancements and, of course, bug fixes. As an example, according to our bug database, we resolved almost 2,500 issues in JDK 11. Oracle engineers resolved most of those, but we had significant contributions from engineers at other companies, including SAP, Red Hat, Google, and Belsoft, along with a handful of individuals. Returning to our timeline, the 6-month cadence will enable Java to compete well with other platforms. But you might be wondering, what about updates? What about security fixes? What about patches to critical bugs? The plan in the OpenJDK community is to update the current feature release for at least 6 months. That's 2 quarterly update releases. And then every 3 years, we'll declare a long-term support release. The first is JDK 11, shipped this past September, and the next will be JDK 17 in September of 2021. If you'd like, you can imagine JDK 8 being way at the top there as the long-term support release that preceded 11. Each of these long-term support releases will be updated well past the beginning of the next long-term support release, and possibly even longer. Now, because of this pattern, you might think that non-LTS releases are in some way experimental. Oh, it's just a fancy name for a beta. You don't need to take it very seriously, and you shouldn't really use it. No, that's completely untrue. Every release is production ready. What differs is only the support timeline. So, you have a new kind of choice to make. You can take the blue pill or the red pill. You take the blue pill, you wake up in your bed and continue to develop and deploy uncomfortable, conservatively managed, and slow-moving long-term support releases with an update release every quarter and a major migration every 3 years. You take the red pill, you go down the rabbit hole, where you can enjoy the latest language features, API enhancements, performance improvements, and bug fixes with a minor migration every 6 months. It's up to you. All I offer is the truth. If you do choose the LTS path and take the blue pill, you might be wondering, who will produce your update releases? Again, you have a choice to make. Since JDK 9, Oracle contributors in the OpenJDK community have focused and will continue to focus primarily on feature releases rather than on updates. Oracle will ship OpenJDK builds under the GPL for the first 6 months of each feature release, the GA release plus 2 updates, whether the release is a long-term support release or not. After that, Oracle will offer long-term support builds, but in a change from the past, these will be available only under a commercial license that allows free use for development and testing, but requires payment for use in production. Now I know that might sound scary, but don't worry. Java is still free. All of the code is still available under the GPL for anyone to build, test, publish, update, and support. Oracle engineers won't contribute to, much less lead, the LTS releases, as they have in the past. But the OpenJDK community as a whole has a proven track record of transitioning the leadership of update releases from Oracle engineers to non-Oracle engineers. We did that for JDK 6 and JDK 7, and I expect we'll do it again for JDK 8 and then JDK 11. This is not just my personal fantasy. Andrew Haley, Red Hat's Java Platform lead, has assured everyone, for example, whether by Oracle or Red Hat or someone else, JDK LTS releases will continue to be supported. We all have a lot invested in Java, and we won't let it fall. So the LTS work will carry on in the OpenJDK community as it has in the past. You'll be able to get carefully built, well-tested JDK LTS builds based upon that source code in most any Linux distribution, whether derived from Red Hat, Debian, Gentoo, or Arch. If you're not on Linux, you'll be able to get LTS builds for free from a variety of providers. Now, for this plan to work, it's critical that you be able to switch from one provider to another, whether from Oracle to someone else, or from someone else to Oracle, or from someone else to someone else. In past releases, that wasn't possible, since Oracle always held back a few so-called commercial features that were available only to paying customers. This included application class data sharing, Java Flight Recorder, Java Mission Control, and the Z garbage collector. To enable such switching and to establish a level playing field, over the past year, Oracle open-sourced these commercial features. So now Oracle builds and OpenJDK builds are functionally interchangeable. You can switch from one provider to the other as you please. When you choose a provider, you might want to consider those with a depth of knowledge that comes only from a long-term investment in the platform. You have a choice. You can take the blue pill or the red pill. You can choose the conservative LTS path and take the blue pill with a major migration every 3 years. This can be a good choice for conventional enterprise-style deployments of large applications on large servers. Or you can choose the aggressive feature release path and take the red pill with a small migration every 6 months. This can be a good choice if you're deploying to the cloud or to app stores, embedding the Java modules that you need right with your application. If you choose the LTS path and take the blue pill, then you shouldn't ignore the non-LTS releases. A bit of advice. If you maintain an infrequently migrated system, then you should still test it with each non-LTS release. That way you'll be nearly ready for the next LTS release by the time it's available. You can spread the migration effort out over time. If, on the other hand, you choose the adventurous feature release path and take the red pill, you're going to migrate to each feature release as it becomes available, so make sure that your tools and dependencies can keep up. Many will be able to keep up, but some won't, especially if they're essentially unmaintained, so plan with care. To sum up, we're evolving the platform at a more rapid pace. We're doing this in order to keep up with competing platforms. We have broken a few things, and will continue to do so in order to make Java a better fit for modern applications. Are these changes really all that scary? No, I don't think they are, for 4 reasons. First, we'll always give advance notice before removing anything. We'll only do so when there's a very good reason. We don't want to break existing code unnecessarily because, after all, compatibility remains one of the core values of the Java platform. Second, you have a choice to make, which you didn't have before. You can take the blue pill and migrate every 3 years at a comfortable, stately pace, or you can take the red pill and enjoy the latest features and fixes every 6 months. Third, it's true that Oracle will no longer provide free long-term JDK updates, but Java is still free. Free updates will be available from a variety of other providers, including all the major Linux distributions. If you want active support, rather than just updates, you're probably going to have to pay someone or else do it yourself, but that's always been the case, so choose your provider wisely. Fourth and finally, yes, we did break a few things. Migrating past Java 8 may require some work, but it might not be as hard as you think. All three of the major IDEs already support most of the new language features. Many popular tools, libraries, and frameworks already support JDK 9, if not JDK 11. And you don't have to take my word for it. As you may recall from last year, just after Java 9 was released, I asked on Twitter, do you maintain a popular Java library, framework, or tool? If it works fine on JDK 9, then please reply with its name and version. That was a year ago. So shortly after JDK 11 was released, I asked, do you maintain a popular Java library, framework, or tool? If it works like heaven on JDK 11, then please reply with its name and version. Thanks to Sam Brannon of the JUnit team for that hashtag. There were many, many responses. All 93 of these libraries, frameworks, and tools work just fine on JDK 9. Some worked without change. Others, in other cases, their maintainers fixed them. In many of those cases, it wasn't that hard. This list includes the build tools, Ant, Maven, and Gradle, test frameworks, JUnit and TestNG, popular libraries such as ByteBuddy, Jackson, Log4j, Hibernate, Juke, and Jetty, and the entire Spring framework. 51 of these components work not just fine on JDK 9, but like heaven on JDK 11. Since that transition from 9 to 11 is much easier than the transition from 8 to 9, I expect that the rest of them will catch up in short order. My most urgent advice to you today, then, is this. If you're using Java 9 or later, upgrade to the latest versions of all your tools and dependencies. Because everything changes, and nothing stands still. Don't believe a word I've said. Thank you very much.